Hello and welcome to our discussion on weather radar. In this video we're going to talk about the basic operating principles of weather radar. Weather radar uses electromagnetic radiation to detect targets in the atmosphere. Electromagnetic radiation is made up of an electric field and also a magnetic field that is orthogonal to the electric field. It propagates through the atmosphere at the speed of light, and based on that principle we can detect the distance and the range and also the intensity of targets out at a distance from the radar. The part of the electromagnetic spectrum that radar operates in is the microwave. And you're probably familiar with microwave ovens. They radiate at a frequency of about 3,000 megahertz. And weather radars also radiate in that range. And we'll look at that in a little bit more detail. There's a relationship between frequency, wavelength, and also the speed of light. Here are some common radar wavelengths. We classify these as bands. You can see the shortest bands or the shortest wavelengths are up top and the longest wavelengths are at the bottom. These wavelengths are more or less the center of this band. The bands range from 0.5 centimeter wavelength all the way down to 20 centimeter. And they have corresponding frequencies. We'll look at the relationship between frequencies and wavelength here shortly. But the bands are something that you need to become familiar with. We're going to be spending more time talking about S, C, and X band. L band is also somewhat important. But they also have shorter wavelengths are the K bands. There's also a KU and a KA band. Now the reason why I have so many different bands or different wavelengths is because you want to see different things in the atmosphere. Objects in the atmosphere that are very small are best sampled by very short wavelengths. Objects that are very large in the atmosphere are best sampled by longer wavelengths. So the wavelength that you select for your radar determines the smallest object that you can see. Also, attenuation is affected by the wavelength. Generally speaking, longer wavelengths attenuate less, shorter wavelengths attenuate more. Attenuation is simply the dissipation or absorption of electromagnetic radiation as it travels through the atmosphere. You want your radiation to travel great distances so you have a good range on the radar. If there is something that's attenuating the energy or the power as it travels out, you won't be able to see things farther away from the radar. We'll talk more about attenuation later on. Also, the wavelength that you pick determines the size of the antenna. Generally speaking, very large wavelengths or long wavelengths require bigger antennas, and smaller wavelengths require smaller antennas. And then finally, the size of the radar beam. Generally speaking, longer wavelengths require bigger antenna to produce a smaller beam. So I did mention earlier that there's a relationship between frequency and wavelength. Here's the equation. And the equation is a relationship between the speed of light, the wavelength, and the frequency. Remember, all of these units need to be, or all of the terms need to have common units. The common unit for frequency is hertz, and hertz is a cycle per second. The common unit for wavelength is meters. And of course, the speed of light is measured or is given in meters per second. So the basic operating principle of radar is that electromagnetic pulses of radiation travel through the atmosphere at the speed of light. These pulses are then either refracted, absorbed, or reflected. Refracted means that some of the radiation is traveling forward, but perhaps at a different angle than the angle that was sent out by the radar. Could be absorbed by the particles out there at a distance, or it could be reflected back to the radar, and that's what we call backscatter. So the amount of energy that is reflected or backscattered to the radar of course, depends upon the size of the particles, also the wavelength, and only a very small part of the energy that was transmitted actually makes it back to the radar. So these returns are very, very weak, or these echoes are very weak. You need a very sensitive receiver to detect the power coming back, and that is measured, and that determines your radar intensity. So that is the basic operating principles of radar.